Hi students, and we're continuing our look at relations and functions. So let me just grab my little hand tool here. So we've got some new definitions here. So first word, domain. Domain is the set of all permissible input values. So remember, your input values are along the x-axis. So these are the set of all the different values that we use as inputs. The range, the set of all output values of the dependent variable, that's the set of all the values that our relation uses on the vertical axis. So it's the set for domain, all the horizontal values that are used, and for range, all the vertical values that are used. So let's take a look at our red relation here first. So notice that the red relation, there's no gaps, there's no holes, and these two arrows mean that they continue off in these directions infinitely. So if I were to squish this function, this relation here, whoops, let's click off here. How do I get that to stop? Okay, so there we go. So if I were to squish this red line down onto the x-axis, notice that it would cover the entire x-axis and we wouldn't have any gaps or holes. So when that's the case, we say that the entire x-axis is being used. And the way that we do that is we say that we have all real numbers. And because mathematicians work very hard to be lazy, we can say this as all the values of x are in the real numbers. So that's using our notation. And you have this like funny looking E shape here. So I'll show you that in class. So now let's take a look at our range. So again, we'll get our little hand tool. So here, if I were to squash all these red values against the y-axis, so pushing them in, and this line continued infinitely, notice that it would cover the entire vertical axis here. So if we squash this in. So what that says is the range is also all real values. So we can have all real numbers. And because here this vertical axis refers to as our y variable, we can say that y is in R. Okay, sorry, my R didn't look so good there, but you get the gist. So now what we're going to do is we're going to take a look at our blue relation. So notice that from our last video example, what we saw is that this red relation here is a function, but also it's continuous, and then this blue relation is also a function but discrete. So let's take a look at what the domain is for this case. Well, the domain is all the used or permitted values horizontally speaking. So let's see, we've got value at -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So what we're going to do is, because it's not continuous, what we can do is we can list all of those values. So I'm just going to get my drawing tool out here, get a good thickness. So what we say is x is the set, and we start at -4, -3, -2, -1, 0, 1, 2, 3, 4, and it goes all the way to 5. We use these kind of weird looking brackets here for set notation. So the domain x is the set -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So what about the range? So here we're going to use, again, y, semicolon. Ooh, my brackets are not looking good today, I apologize. So now what we're interested in is just our y values. So let's get my hand tool here. So we can see that the y values go as low as here. So we've got -1 and -3, -5, -7, and -9. Okay, so let's list those ones. So we'll kind of list them in increasing order. So the smallest value we have is -9, then -7, then -5, then -3, then -1, then 1, then 3, then 5, then 7, then 9. And that closes the set. So here we can see a big distinction between discrete domains and ranges versus continuous domains and ranges. So when we're talking about discrete domains and ranges, what we're going to be doing is we're simply going to be making a list of all the values that are used. Similarly, when we're taking a look at a continuous relation or function, we need to use a different type of notation. We're going to talk about interval notation. So let's take a look at another example. So here we've got a function. It has a point here at -3, comes up to 4. That's where it crosses the y-axis, and then comes and hits right here at +3 on the x-axis. So what we want to do is we want to say, okay, what is the domain of this function? So I'm going to use some color here to help us out. So one way that I like to think about domain is kind of like the domain of a queen. So a queen's domain is all the land that is hers. So if we think of this is, pardon me, this section here, if we squash down this graph all onto the x-axis, so all of these points coming down here, if we squash all this down, we see that our domain is between -3 and +3 inclusive. So we're going to use our inequalities to help us out. So what we're going to say is, well, our boundaries are -3 and +3, and we've got our x in between here. So now what we have to do is we have to have the right inequality symbol. Well, x is definitely less than 3, and x is definitely greater than -3, but notice that this endpoint here and this endpoint here are included. So because these two dots here are shaded, it's not just greater than or less than, but -3 is less than or equal to x, that's what that extra line means, and x is less than or equal to -3. Now this is one way of writing this. Another way that we can write this is using bracket notation. So we can also say that we use square brackets when we have a closed dot point. So this is -3, 3, square bracket closed. So these two notations mean the exact same thing. Both are saying that all the x values permitted are between and inclusive of -3 and +3. Now let's take a look at the range. So I'm just going to get rid of our green here. So now when we talk about range, let's go back to the queen example. So the queen's domain is all her land, and how does she protect her land? She protects it with the range of her cannons, or trebuchets, or her artillery. So for instance here, what we want to do is we want to see squishing this function down against the y-axis. So if we squish this function down against the y-axis, what we can see is that we get all of these y values here. So where do they range from? So they go as low as 0 on the y-axis. So let's get that. So our lowest point is 0. And what's the highest point on the y-axis? The highest point is 4. Now, are those points included? Are endpoints included or not included? Well, they're both shaded in, and this one intersects here, so they're both included. So it's 0 is less than or equal to y, less than or equal to 4, and using bracket notation, it's square bracket 0, 4, square bracket. Okay, so let's take a look at an example here where we have some points that are not included. So here we have another relation. This is a function because it passes our vertical line test. If I draw a vertical line through here, it doesn't intersect more than one point of our relation. So let's take a look here. I want to know what the domain is. So we've got this open dot here. So that means that this value of -4 is not included. So let's get out our pen here. So I've got this -4. Well, it's there, but it's not included. So using bracket notation, when a point is not included, we use a curved bracket. Now let's see. And the x value that's farthest to the right is 3. So we've got x and 3. And here using bracket notation, square bracket meaning the 3 is included. So this is what we would say for the domain. The domain of the function is curved bracket -4 comma 3 square bracket. Now how we would do it using our inequalities is we would say that -4 is strictly less than x, not equal to, but because this point here on the end on the right side is included, x is less than and or equal to 3. So that's our domain. So what I'd like you to do is I want you to try pausing the video and try out what is the range in both notation formats. Okay, so let's see what we get here. So we're going to start off, let's get my little hand here, by taking a look at, okay, what's the lowest value that y takes on? Well, the lowest value that y takes is this value right here, 3. What's the highest value, the largest value that y takes? Okay, 6. But this endpoint here is not included. So let's put this in. So the lowest value we had was 3. The highest value we had was 6, but it wasn't included. So we got 3 is less than or equal to y, and y is just strictly less than 6. And to use our bracket notation, we've got square bracket 3, comma 6, curved bracket. So these represent the exact same pieces of information. Now if you're having trouble seeing this, let's use some color to help us out. So the idea here is, with our domain, if I squish this function down to only being on the x-axis, what I'm going to have is this is one continuous piece all the way from -4 to 3. Oops. That didn't help out. Let's try that again. To 3. Okay? So that's where our -4 and 3 come from. So similarly, let's get rid of our green here. If I grab another highlighter, and now we're smushing everything onto the y-axis, what we can see is we get this section here. So what's this interval? Well, this interval is, the lowest is 3, and that's where this guy comes from. And the highest y value we get is 6, and that's where this guy comes from. So let's try out another example here. And this time I'll give you a relation which is not a function. Okay, so in this case, let's get our hand tool. What we have is we have a special shape. This is called an ellipse. So this ellipse, I've marked the extreme point. So the furthest it comes out this way, its coordinate point is -5, 1. The furthest to the right it comes, its coordinate point is 8, 1. The highest it comes is 6, 3, and the lowest coordinate point is 6, -2. So what we want to do is, well, first notice that this relation is not a function, because if I draw any vertical line through this, I'm always going to hit more than one point. In fact, only at the tangent will I hit one point. So because there exists even one vertical line that I cannot draw without hitting more than one intersection, this means that this cannot be a function. It doesn't meet our mapping rule. So let's take a look at the domain here. So let's get out the green highlighter. So notice that the domain, if I squish this down to the x-axis, it's this section right here. So what are the values in the domain that we're allowed to have? Well, you can have from -5 included. Let's make that 5 a little bit bigger. And then what's the furthest to the right I can go? Well, 8. And because they're both included, it's -5 is less than or equal to x, and x is less than or equal to 8. Using our interval notation, we get -5, 8, both with square brackets. So I want you to pause the video and try finding out what the range is in both notation types. So what we want to do is we want to see what values we have if we squish this against the y-axis. So squishing this against the y-axis, we would have all of these values here. So the highest it reaches is positive 3. The lowest it reaches is negative 2. So let's put this in here. So what we're going to have is the lowest is negative 2. The highest is 3. Both of those points are included. So we use the proper inequality and we use y. So that's using your inequality notation. So now let's use our bracket notation here. Because the negative 2 is included, negative 2 square bracket, comma 3 squared bracket. And there are our domain and range.